Hi everyone, my name is Nurul Farzana and today I'll be sharing how to read and understand the periodic table. Let's get started. The periodic table is arranged by groups and periods. Elements in the same group have the same number of outer electrons, which makes them react similarly. This helps predict an element's reactivity, physical properties, and bonding behavior. As you move left to right across a period, atomic size decreases. This happens because the nucleus gains more protons, pulling electrons closer. The stronger pull makes the atom smaller, even with more electrons. Now, let's move to the next part. Moving down a group, atomic size increase. More electron shells creates a shielding effect, reducing the nucleus pull on outer electrons. This makes atoms at the bottom larger than those at the top. Now, let's look at what happens to atomic size as you go down a group. As you move down, atomic size increase. Why? Because atoms gain more electron shells as you go down the group. These extra shells shield the outer electrons from the pull of the nucleus. For example, in group 7, reactivity decreases as you move down. Larger atoms with more electron shells make it harder for the nucleus to attract extra electrons. This is why fluorine at the top is more reactive than iodine at the bottom.
Hi, my name is Putrino Aizora, and I'm going to explain about valence electrons. Let's get to know all about the valence electrons. First, the group of an element is determined by valence electrons. Next, group 18 is the only group with no charge because all elements are stable, mostly with full octet. For helium, it's a complete duplet. Lastly, for transition metals, they can form cations of different charges that ranges from +2, +3, and +4. For group 1, the valence electrons is 1. The charge of elements from group 1 is +1. Let's take lithium as an example from group 1. Electron configurations for lithium is 1s2, 2s1. The valence electron is 1. That's why lithium is from group 1. For group 2, the valence electron is 2. The charge of elements from group 2 is +2. Magnesium from group 2 has electron configuration of 1s2, 2s2, 2p6, and 3s2. The valence electron is 2. For group 13, the valence electron is 3. The charge of elements from group 13 is +3. Boron from group 13 has 1s2, 2s2, 2p1 as electron configurations. Therefore, the electron valence is 3. For group 14, the valence electron is 4. The charge of elements from this group is +4. We have carbon from group 14, and the electron configuration is 1s2, 2s2, 2p2. The valence electron is 4. For group 15, we have 5 as the valence electrons. The charge of elements from this group is -3, which makes them anions. We have nitrogen for group 15, and the electron configuration is 1s2, 2s2, and 2p3. The valence electron is clearly 5. For group 16, the valence electrons is 6. The charge of elements from this group is -2, which also makes it anions. We have oxygen from group 16 that has 1s2, 2s2, and 2p4 as their electron configurations. The valence electron is 6. Group 17 has 7 as valence electrons. They're also anions, and the charge is -1. And for the last example, which is fluorine from group 17, it has 1s2, 2s2, and 2p5 as electron configurations. The valence electron is 7.
Good morning, everyone. Today we will be exploring the topics of metals and nonmetals on Group 1 and 2 based on the periodic tables. The introduction, Group 1 alkali metals. Group 1 element known as alkali metal, as we know, They are include lithium, sodium, and potassium. They are highly reactive, especially with water, and have one electron in their outer shell, which they lose easily, and they will be they will forming 1 plus ions. Metals and the periodic tables. Metals are located on the left-hand side and in the middle of the periodic table. The elements in group 1 and group 2 are metals, as well as the transition metals in the middle. So this slide we will be comparing properties between metals and non-metals. Metals, we have good electrical conductors, good heat conductors, shiny, high density, malleable, ductile. While non-metals, we have poor electrical conductors, poor heat conductors, dull in appearance, low density, and brittle. So this is the one of the metals properties, which are melting point. Metal have a high melting point. The reason is there is a strong electrostatic interaction between the delocalized electrons and the positive metal ion. A large amount of thermal energy is required to overcome this destruction. A lot of energy also needed to break these bonds. So for the conclusion of my slides, my presentation, alkali metals are very reactive and essential for chemical reaction. Metals have versatile properties due to their structure, and also non-metals, though opposite to metals, they play on critical roles.
Hi, my name is Ainubaki Samtiomawasaki. I'm from Group 3. Today I want to talk about decoding halogens, noble gases, and octet rule. We move at the first slide, which is Group 17, also known as the halogens, includes elements like fluorine, chlorine, bromine, iodine, and astanes. These elements are highly reactive, non-metal, and are known for their ability to form salt with metal. Their activities decrease as you move down the group due to increasing atomic size and shading effects. Halogens have a various application due to their activity properties. They are widely used in disinfectant, halogen lamps, and pharmaceuticals for producing medical compounds. This use leverages their ability to kill bacteria and participate in chemical reaction effectively. Now we move to Group 18, known as noble gases. Includes the elements which is helium, neon, argon, krypton, xenon, and radon. These gases are chemically inert and stable due to their full valence electron shells. They are colorless, odorless, and non-flammable gases. Noble gases have a various applications, like helium, normally used to balance and cooling system, while neon is widely used in everything science, and argon is essential for welding and in light bulbs. Their properties make them ideal for use in environment requiring non-reactive conditions. Now we move to comparison of group 17 and group 18. Group 17 elements known as halogen are highly reactive and exist in various states at room temperature. For example, solid, liquid, or gas. They are commonly used in salt and disinfectant. In contrast, Group 18 or noble gases are chemically inert and exist only as gases at room temperature. Their application include lighting, cooling system, and creating inert environments due to their stable nature. This difference arises from their reactive and electronic configuration, with halogens seeking to complete their valence shells and noble gas already having full valence shell. Now we move to octet rule. The octet rule states that atoms tend to gain, lose, or shell electron to achieve a full valence shell of 8 electrons, similar to the electron configuration of noble gases. However, there are exceptions to this rule. Hydrogen and helium are stable with only 2 electrons in their valence shell. Transitions matter and elements with expand octet rule may also not follow the octet rule, as they can hold more than 8 electrons in their outer shell. The importance of the octet rule lies in its ability to explain chemical formations and serve as a basic framework for predicting the stability and reactivity of the molecules.
Hi everyone, my name is Norelia Natasha. I'm from Group 3 and I'm here going to present about periodic trends. The first periodic trend is atomic radius, the second one is ionization energy, the third one is electron affinity, and the last one is electronegativity. We go through the first one first. The first one is atomic radius, or we can say as the size of the atom. As we proceed downward on the table, atomic size increases. As we go to the right, atomic radius decreases because we are moving within a shell and each element to the right has one more proton in the nucleus than the last. So there is stronger electromagnetic attraction felt by the electrons and the radius shrinks. That means overall atomic radius increases going this way on the periodic table. The ionization energy. This energy required to remove an electron from the atom. It will always be an electron in the outermost shell. The electromagnetic force that attracts the electrons to the protons drops off very quickly with distance. So the further away an electron is from the nucleus, the easier it is to pull it away. The ionization energy trend is precisely the opposite of the atomic radius trends, because when it goes this way, the ionization energy will increases. Continue to the third one, which is the electron affinity. This is exactly the opposite of the ionization energy, since ionization energy is how much energy you need to remove an electron, and electron affinity tells us how much an atom wants to gain an electron. Disregarding the noble gases and their shells are full, electron affinity increases this way. Fluorine has the highest electron affinity because if it gains one electron, it will have a full shell or noble gas electron configuration. Looking at the opposite corner of these elements, they don't want to gain electron, but they would rather lose them. The last one is electronegativity. It is the ability of an atom to hold electron tightly. It will increase this way because a smaller atom like fluorine with more protons for its energy level or higher effective nuclear charge will hold electron the best. Again, we will disregard the noble gases for this trend.
Assalamualaikum and hi everyone. My name is Nur Afifah Sahira binti Muhammad Sharudin and today I'm going to talk about transition element. So, firstly, we need to know what is transition element. Basically, transition elements are located between groups 2 and group 13 in the periodic table of elements. For example, transition elements include chromium, manganese, iron, and copper. Next, there are 4 important properties of transition element. Firstly, transition element is a solid with a glossy surface. Then, it is very hard compared to metals in group 1 and 2. Third, it has a high density. Lastly, it has high melting point and boiling point. Let's move on to the special properties of some transition elements. First, transition element can be functioned as a catalyst. What is catalyst? Catalysts are used to increase the rate of reaction, such as iron powder in Haber process to make ammonia, platinum in Oswald process to make nitric acid, and nickel in hydrogenation process to make margarine, and also vanadium 5 oxide in contact process to make sulfuric acid. Secondly, it can form colored ions. Most of the transition metal compounds show particular colors. For instance, copper ion can form blue color, while nickel can be in green colors, and same goes to manganese can form a pink color. These colors were formed due to the presence of transition element. Third, transition element has more than one oxidation number, like copper have +1 and +2, chromium have +3 and +6, manganese have +2, +4 and +7, while iron have +2, +3. Next, transition metals can form complex ions. Complex ions contain a single metal ion surrounded by non-metallic ions or molecules. For example, hexacyanoferrate 2 ion and hexacyanoferrate 3 ion, and so on. Last but not least is other functional of transition elements such as iron for build bridge, titanium for making paint, iron and steel for making engineering metals, manganese to make tinted window glass.